The James Webb Space Telescope has just sent Earth a tremendous rebuke, and it's moving closer. This cautioning comes from the exoplanet Proxima B. With each new picture sent back, extra requests arise, leaving experts frightened. Each review from this distant planet makes us wonder more about the mysteries of the universe, creating questions about an expected threatening planet near Earth. Could there be an adjoining outcast planet that has disagreeable intentions? Could Proxima B, of all places, address a threat to our actual presence? The subject of untouchable life has dazzled humanity for many years. However, with current innovation like the James Webb Space Telescope, it has become an inquiry we can investigate more thoroughly than ever before. Yet the universe isn't making it easy to track down answers. We continue to utilize our best devices, such as the James Webb Telescope, to get brief looks at distant planets and universes, hoping to find bits of evidence that might demonstrate life beyond Earth. We should be hopeful, but every new picture and snippet of data usually reminds us of how little we really know. While these revelations could be memorable, they also highlight the endlessness and multifaceted design of the universe, leaving us with additional inquiries than answers. Getting a handle on a far-off planet like Proxima B could reclassify our place in the universe. For scientists in space science, this is exciting, but for the general population, it frequently feels like just one more piece of space news, distant, dynamic, and sometimes overwhelming. These discoveries raise more questions than they answer, driving many to consider how this affects life on Earth. Could Proxima B really harbor life or even intelligent life that might one day present a danger to us? Notwithstanding the epic force of the James Webb Space Telescope, it can unfortunately show us a limited amount. Sure, we've learned some unimaginable things, like the fact that we now have stunning new pictures of Proxima B and that the universe is altogether larger than we ever imagined. But what comes next? The viable implications of these revelations can feel as big as the universe itself. Proxima B, discovered in 2013 due to its gravitational cooperation with its star, was a significant scientific breakthrough for many specialists. Finding this exoplanet was like discovering a new celestial neighbor. Proxima B is just somewhat bigger than Earth, and it orbits its star every 11.2 days, making it an interesting subject for further examination. From a scientific perspective, the possibility of a distant universe so close to our own is invigorating. Yet, for most, it's hard to connect with a place that is 25 light-years away. To put that into perspective, even the fastest rocket humans have made would require many centuries to reach it. Imagine what it might be like to stand on Proxima B. Its star, Proxima Centauri, would appear as a faint red light overhead, much cooler and darker than our sun. Proxima B orbits so quickly that a year there lasts a bit over 7 days. One side of the planet constantly faces the star, meaning it's locked in eternal light, while the opposite side is shrouded in timeless night. It sounds like something out of a sci-fi novel, but the reality would be much more extreme. On the bright side of Proxima B, any water would undoubtedly boil into steam due to constant exposure to heat. On the dark side, however, the water would freeze into solid ice. The planet's star, Proxima Centauri, is also not a peaceful and consistent neighbor like our sun. It throws out dangerous flares and intense radiation, causing the surface of Proxima B to be a hazardous spot for life as we know it. This isn't the sort of area where people would want to settle. Interest in finding life beyond Earth peaked in late 2020 when researchers detected a strange signal coming from the Alpha Centauri system, where Proxima Centauri is located. This signal had an unusual frequency of 982.551 MHz, which grabbed everyone's attention. Such a signal could theoretically be a sign of advanced technology, but it's too early to make any conclusions. More recently, the James Webb Space Telescope sparked even greater excitement by suggesting that Proxima B could have water vapor in its atmosphere. Water, as we know, is a crucial element for life, and its presence could be a game changer. To better understand how much water is present on Proxima B, analysts are using advanced techniques like spectroscopy. This method allows them to detect the gases surrounding the planet, behaving like a cutting-edge investigative tool. By studying the planet's light spectrum, researchers can identify specific gases like oxygen, methane, and carbon dioxide, all of which are essential for life. Environmental modeling is another important strategy. By using automated simulations of Proxima B's climate, scientists can make reasonable conclusions about its conditions. These models serve a similar purpose to how researchers use dinosaur fossils to recreate what dinosaurs might have looked like. However, the more we learn about Proxima B's environment, the more we are reminded of the astounding diversity of life forms that exist here on Earth. Extremophiles, for instance, are tiny creatures that can survive in extreme conditions such as extremely hot springs, acidic lakes, and the freezing cold of Antarctica. These tough animals show that life can adapt and thrive under conditions once thought impossible. Could life on Proxima B be just as resilient? The search for life on Proxima B presents enormous challenges, not just in terms of space travel, but also in proving that life could exist in such a hostile environment. The planet is bombarded by intense space radiation, and its atmosphere may not offer much protection. Furthermore, the distances involved are so vast that new propulsion systems are required to make space travel to Proxima B feasible. Concepts like solar sails, particle propulsion, and even more theoretical ideas like warp drives offer exciting possibilities for future exploration. However, these technologies are still in their early stages and require extensive research before they can be used in real missions. While dreaming about future space travel is exhilarating, we need to stay realistic. Finding life on Proxima B is filled with technological and scientific obstacles. Only by advancing our technology and expanding our understanding of the universe can we hope to unlock the full potential of distant worlds like Proxima B. This journey is not just about satisfying curiosity. It's about pushing the boundaries of human achievement. Might we one day step foot on Proxima B or even contact life there? As we consider the long journey to Proxima B, finding aliens no longer feels bound to the realm of science fiction but instead appears like a genuine, tangible possibility. This astonishing shift from a distant dream to a scientific endeavor has drawn considerable attention from cutting-edge organizations like breakthrough initiatives. These groups are dedicating significant resources to turning what would normally be an unfathomably long journey, one that could take millennia, into a mission that could be completed in decades. The goal of reaching another star system within a human lifetime has begun gaining momentum and confidence within established scientific circles. However, these grand ambitions are quickly tempered by the stark realities of our current technological limitations. Notwithstanding significant advances in space exploration, traveling to Proxima Centauri, indeed even at just 4.2 light-years away, still presents daunting challenges. Current propulsion systems are simply not fast or efficient enough to make such a journey possible within a reasonable time frame. The Breakthrough Starshot, one of the most ambitious projects, imagines using powerful laser-driven sails to propel small spacecraft to speeds of up to 20% of the speed of light. While this idea shows promise, it is still in the experimental stage and requires overcoming several technical and logistical hurdles, such as protecting against space debris and ensuring reliable long-distance communication. While the dream of reaching Proxima Centauri and potentially finding alien life is closer to reality than ever before, it is still grounded by the limitations of current technology. Accelerating a spacecraft to near-light speeds with today's tools feels exceedingly difficult, like trying to solve a complex puzzle in the dark. Even ambitious projects like Starshot, which aims to send a spacecraft toward Alpha Centauri using lasers, face significant practical challenges. The Earth's atmosphere causes disturbances for the lasers, making it challenging for space-based instruments to work with the precision required. One proposed solution is the use of adaptive optics, smaller lasers on satellites that constantly monitor and adjust to atmospheric disturbances. This system would help powerful ground-based lasers stay on track as spacecraft travel through space. However, the laser propulsion method requires an enormous amount of energy, equivalent to the total energy consumed by the entire Earth in a year, and would only work for a limited time. Imagine setting up 100 million lasers over a vast area just to propel a small spacecraft, only 33 feet wide, to 20% of the speed of light. At this speed, the spacecraft would still require 22 years to reach the Alpha Centauri system, a time frame longer than many people's lifetimes. But the challenge of reaching Alpha Centauri is not just about surviving technical obstacles. There are natural barriers as well, such as the sun's gravity, the presence of space debris, and the sheer enormity of the distance involved, all of which present significant risks. Even communicating with a spacecraft en route to Proxima B would require sending messages through time. It would take nearly 4 years for a message to travel from Earth to reach it. Notwithstanding these complex challenges, the desire to explore other star systems continues to grow. It is driven by humanity's deep love for discovery and exploration, rather than practical need. Even ambitious ventures like Starshot, which intends to send a spacecraft to Alpha Centauri using lasers, face many practical challenges. However, solving these problems could revolutionize space exploration. Still, the potential dangers involved, including communication delays and natural hazards, require careful planning. All things considered, many scientists believe the rewards far outweigh the risks. Finding life elsewhere in the universe, especially on a planet like Proxima B, is worth pursuing. Although the difficulties may seem insurmountable at times, the search for knowledge and the future of humanity in space remain incredibly bright. In the future, the question will not just be whether we can reach Proxima B or other distant stars, but how soon we will overcome these challenges and make new discoveries that will redefine humanity's place in the cosmos. As we continue to delve deeper into the mysteries of Proxima B and other distant worlds, it becomes increasingly evident that the pursuit of space exploration is not just a scientific endeavor but a reflection of humanity's innate curiosity and desire to expand the boundaries of our understanding. The potential to discover life, or even to make contact with intelligent beings, is a tantalizing thought that drives both the scientific community and the public imagination. However, it also forces us to consider our place in the cosmos and how we might interact with extraterrestrial life, should we find it. The idea of interstellar travel has long been a subject of science fiction, but now, with advancements in technology, what was once a dream is beginning to feel more like a realistic pursuit. The search for habitable exoplanets like Proxima B is just one part of a much larger goal: to expand human presence beyond the Earth. This pursuit has inspired new ways of thinking about space travel, propulsion, and the very nature of life itself. As we push further into space, we are forced to rethink what constitutes life, how it can exist under extreme conditions, and whether our current methods of exploration are sufficient to meet these challenges. While Proxima B stands out due to its proximity to Earth and its potential to harbor life, it is far from the only planet being studied for signs of habitability. Numerous other exoplanets are being discovered every year, many of which are located in what is called the habitable zone of their respective stars, the region where conditions may be right for liquid water to exist. These planets, though distant, provide scientists with valuable data on the types of environments that could support life. However, one of the biggest challenges facing the search for life beyond Earth is the vastness of space itself. Even within our own solar system, the distances between planets are so great that space travel remains a monumental challenge. The idea of reaching Proxima B, located 25 light-years away, or other stars in neighboring systems, requires new technologies that could drastically shorten travel times. Proposals like the Breakthrough Starshot initiative, which involves using powerful lasers to propel tiny spacecraft, offer a glimpse into how we might one day send probes or even human missions to these distant worlds. The concept of reaching distant star systems is not just about the technology we use to travel, but also about the fundamental nature of space exploration itself. It's about understanding the laws of physics, the behavior of space-time, and the challenges of living in environments completely different from Earth. For instance, how would humans survive on a planet like Proxima B, where radiation levels are much higher than on Earth? Could we create habitats that protect against the harmful effects of radiation, while also providing the necessary resources to sustain life? These questions are not just speculative. They are essential to the future of human exploration. While we have yet to develop the necessary technologies to travel to other star systems, the advancements we make in this field will have far-reaching implications for humanity's future. The quest for interstellar travel could lead to breakthroughs in energy production, propulsion, and space habitats, technologies that could one day be used to support human life on Earth as well as on distant planets. Another intriguing aspect of this exploration is the potential for discovering entirely new forms of life. On Earth, life has evolved to thrive in a wide range of extreme environments, from the deepest oceans to the highest mountains. The study of extremophiles, the organisms that survive in these harsh conditions, has expanded our understanding of the adaptability of life. Could life on other planets, such as Proxima B, have evolved in ways we cannot yet comprehend? The discovery of such life would revolutionize our understanding of biology and the very definition of what it means to be alive. In the end, the search for life on planets like Proxima B is not just about finding evidence of other civilizations. It is about answering some of humanity's most profound questions. Are we alone in the universe? What is the future of our species? And how can we continue to grow and adapt as we venture further into the cosmos? While the answers may take centuries to uncover, the journey itself promises to be one of humanity's greatest adventures. Every step we take brings us closer to unlocking the secrets of the universe. And in doing so, it redefines our understanding of life, space, and our place in the cosmos.